Hello, everyone. I want to welcome you again to Math 1035. This will be the first lecture video for the semester, and we're going to just start with some algebra review. So, the first thing that we want to talk about in our algebra review session are the classifications of numbers. So, we will deal with the real numbers um, throughout the entire duration of the course. Real numbers are a concept that you definitely have learned in the past and have used on a daily basis, but maybe you didn't know what you were using. So, real numbers are classified as follows. We have the natural numbers of 1, 2, 3, 4, etc. And then we have the whole numbers, which are 0, 1, 2, 3, 4, and continued. The difference between those two would be that whole numbers include 0. Then we have integers. Integers are whole numbers that can be negative or positive. So, for example, negative 52, that would be an integer. 1's also an integer, and 36 would also be an integer. And then as we get a little bit more broad, we have the rational numbers. So, all numbers that can be written in the form of p divided by q, where p and q are integers. So, for example, 3 over 2, 10 over 7, um, any of those can classify as rational numbers. Irrational numbers are just real numbers that are not rational. All right, and so we have properties of those real numbers. Some of these things you have probably seen before, but just to kind of go over them again. So we have the commutative property, and I have two columns here. Addition is on the left, and multiplication is on the right. So the commutative property of addition says that a plus b is equal to b plus a. And then, in a similar sense, with multiplication, a times b is just equal to b times a. So 3 times 2 is equal to 6. 2 times 3 is also equal to 6. And then we have the associative property. And the associative property takes the association of the groups and just regroups them. So here I have A plus B together, and I'm going to add C on. Here I have A plus the group of B plus C. So that says that I can reassociate the numbers in any manner, and I will get the same result. The same for multiplication. Then I have the identity properties. The identity properties for addition says that anything plus 0 just results in anything. So 100 plus 0 is just 100. 1,000 plus 0 is just 1,000. And then in a similar sense, the identity property for multiplication, a times 1 is just equal to a. So 52 times 1 is just equal to 52. I have the inverse property. The inverse property says that a plus its opposite, so basically think of subtracting itself, will always result in 0. So a plus negative a will be 0, so 8 plus negative 8 is just 0. For multiplication, I have a times 1 over itself will equal 1. So 8 times 1 over 8 will just get me back to 1. And then lastly, I have the distributive property. And the distributive property says that whatever's outside of the parentheses, I just distribute it and multiply it by whatever's in the parentheses. So I have a times b plus a times c. And so that will end us on the properties of real numbers. And so here would be some examples of properties of real numbers that I just discussed in the last slide. So if I have anything 6 plus x plus 9, and I rearrange that in any manner, as long as the numbers stay the same and I'm dealing with addition or multiplication, then then that will stay the same. I'll have the same result. Same for the associative property. If I regroup my groupings here, no matter how I do that, as long as the numbers obviously stay the same, then I will still be equal on both sides. For the additive identity, -8 plus 0 just gives me -8. The multiplicative identity says -9 times 1 just gives me -9. And then the inverse property says 9 plus a -9 will just give me 0. And so now we have orders of operations that we can do with manipulating equations or expressions. So this is the book's terms for using order of operations. So we want to find all powers and roots working from left to right. And then we want to do any multiplications or divisions in the order in which they occur, working from left to right. Finally, do any additions or subtractions in the order in which they occur, working from left to right. So notice that we're always working from left to right, but there is a simpler way to think about this, which I will cover on the next slide. All right, and so the way I want to cover this orders of operations would be PEMDAS, or maybe you learned it as like, please excuse my dear Aunt Sally. So that tells me that I need to do parentheses first, and then I will do exponentials, then multiplication, division, addition, and subtraction. All right, so again, parentheses, exponentials, multiplication, division, addition, and subtraction. And I'll have an example on the next slide. So here's an example of using orders of operations. So I want to use the order of operations to evaluate each expression if x is -2, y is 5, and z is -3. So what I'm going to do is I'm going to substitute in each number for the corresponding letter. So -4 times -2 squared minus 7 times 5 plus 4 times -3. And I'm writing with a computer mouse, so hopefully I'll have my iPad up and running soon. But here is how I want to do this. I want to just plug in each of those values. So PEMDAS, or please excuse my dear Aunt Sally, tells me I should do parentheses first. That is exclusive to an example like this, when we have something maybe like 2 plus 4 in parentheses, then you would want to do that first. But for this case, we don't have that. I'm using parentheses as another way to say multiplication. So I'm going to do my exponent first, since I have no parentheses. I'm going to do my exponents first, so -2 squared. So make sure in your calculator you do -2 as a quantity, so meaning it is -2 as a whole. It gets squared and makes it 4. So I have -4 times 4 minus 7 times 5 plus 4 times -3. Okay. All right. And so now that I've taken care of my exponents, I can keep going with PEMDAS. So I can use multiplication. So here I have multiplication. -4 times 4 is -16. I have -7 times 5 is -35. I have 4 times -3 is -12. And you can plug these each individual in the calculator. And so now I've moved on to from multiplication. I have no division, so I have addition and subtraction left. And so here I just have subtraction, so I'm just going to do it from left to right. So -16 minus 35 is -51. minus 12 is a negative 63. So my final answer would be negative 63. You can also check that in the calculator. All right, so here is a little bit more complicated version of doing orders of operations. So I'm going to set it up for you. I'm going to take these values and I'm going to plug them in. So x is negative 2, y is 5, and z is negative 3. So I have 2 times negative 2 minus 5 squared plus 4 times 5, all divided by negative 3 plus 4. Okay, and so what I want you to do now is pause this and attempt this on your own. All right, so hopefully you had the opportunity to pause the video and attempt this one. So again, just following my PEMDAS. So I'm going to start with parentheses this time. So I have 2 times, so I have negative 2 minus 5, which comes out to negative 7 squared plus 4 times 5, all divided by negative 3 plus 4. Okay. All right. So that takes care of my parentheses. Now I want to do exponents. So I'm going to go ahead and combine a step here. So I'm going to do my exponent. So negative 7 squared is 49 times 2 is 98. So again, I just did negative 7 squared times 2. All right. And then 4 times 5 is 20. Sorry, my writing's getting small. I'll come over here. Okay. So now I have addition and I have division. This is the caveat to orders of operations. Okay. If you are in a situation like this, you have to complete your addition steps before you can do your division steps. Okay, normally multiplication and division would come before addition and subtraction, except in a situation like this. So I'm going to do 98 plus 20, which is 118, and negative 3 plus 4 is just 1, so it comes out to being 118. And that will end us for our orders of operations. You will do plenty of these throughout the semester, but that is as far as the examples. All right, and so now I want to talk about some common math symbols. So these are just some symbols that you're going to see over and over again. And I wish I had my iPad to write these down, but this is called the square root. So you can find this in the textbook, but this is the square root. This is called the absolute value. Less than or equal to, greater than or equal to. These are parentheses, and these are called brackets. Square root says, okay, whatever number it takes to generate, or let me rephrase this. So for an example, 2 squared is 4, so the square root of 4 is 2. For 9, so 3 squared is 9, so 9 squared, or the square root of 9 would be 3. Okay, so square root just undoes the squaring of a number. Absolute value is a distance from 0, meaning that if it's a negative 25, that means it's 25 units from 0, whether it be positive or negative, doesn't matter. So the absolute value will strip the number of its sign. Positive will stay positive. Negative will become positive with absolute value. Less than just means any number that is to the left of it on a number line. So like 2 is less than 3. Less than or equal to means that it can be equal to that number. So for example, x is less than or equal to 5 means that x could be anything to the left of 5 or could be equal to 5. And then in the opposite direction, we have greater than and greater than or equal to, meaning anything larger than the given number. So x is greater than 5 would mean anything 10, 11, 12, 150, right? X is greater than. If it's greater than or equal to, then it means that it could also be equal to 5. Parentheses and brackets, I want to talk about them on the next slide. Okay, so parentheses and brackets are used in interval notation alongside of less than, greater than, less than or equal to, greater than or equal to. So if I had an inequality like this one here on the top row that said, okay, I have a that is less than or equal to x that is less than or equal to b. What I am saying is that x could be equal to a, it could be equal to b, or it could be anything in between. So when I see something that has a less than or equal to sign, so if I see this little equal sign underneath, then I want to use a bracket, okay? Because I am saying in this interval notation category in the middle column that a could, or a is included, so the bracket includes the left value, the right bracket includes the larger value of b, so x here could be a, could be b, or could be anything in between. So the explanation is that both a and b are included. Okay. If I see something that is just a less than sign with no equal to mark underneath it, then I'm going to use a parenthesis. And a parenthesis says that we're not going to include that number. So for example, x could be, let's say b is 5. Then x could be 4.99999, but it will never be 5. I'm going to use that to say, okay, well, x is going to get really close to this number, but it's never going to include that. All right. So a would be included because of the bracket and the equal sign here, but b is not because of the parenthesis and the just the less than sign. Same thing here, just on the opposite side. A would be included, or a is not included because we have a parenthesis and we have a less than sign. B is included because we have a bracket. Okay, so x could be, say b again is 5, then x could be anything up to 5, but it's never going to be whatever a is. It might be, if a is -2, it might be -1.99999, but it'll never be -2. And then for the last example, we have less than and less than, which means we have parentheses and parentheses, meaning that we will never be A or B, but we can be anything in between. So this concludes the first video of the 1035 class. And if you have any questions, please email me.